4 years ago, I got the Precision Matthews PM30-MV mill and converted it to CNC. It's been a really fun journey that's taught me a lot and given me the ability to make all kinds of really cool things, but something that's plagued me from the very beginning was this flimsy base I got from Precision Matthews with the mill. At the time, I had no idea the mistake I was making, and if you're watching this video, you're very likely thinking about doing the same thing. So in this video, I'm going to show you what I did to upgrade the base to something more heavy duty, and I'll also talk about the impact it's had on the performance of the mill. I don't want this to come off as a slight against Precision Matthews. Their mills for the price are second to none, and if I were to do this all over again, I'd still get one of their mills, but I'd definitely not opt for the base they sell with at least the PM30. And here I'm going to show you why, so let's get right into it and talk about the upgraded base and the performance gains that came with it. I decided to make it out of 3x3 by 1/4 inch square tubing, meaning that the outside dimension of the tubing is square and measures 3x3 inches, which is roughly 75 millimeters by 75 millimeters. And the wall thickness of the tube is 1/4 inch or a little over 6 millimeters. Then on top of the frame, the plan is to bolt a 3/4 inch thick plate that the mill is going to sit on. Now, this is definitely overkill. All said and done, this base weighs a little more than 320 pounds or 145 kilos, but I've spent a little over 4 years at this point with a base that I was very unhappy with, and I wanted to make sure I wasn't leaving anything on the table with this upgrade, and so this design is something I was confident would achieve that. I had a hard time finding the bolt pattern of the base of the PM30 mill, so for those of you wondering the same thing, mine is a 335mm by 380mm bolt pattern, and the mill comes with M8 bolts, but the clearance holes in the mill's base can easily accommodate 1/2 inch bolts or M12 bolts, which is what I decided to install as part of this upgrade. Now, I've heard that there are 2 different iterations of the PM30 base with different bolt patterns for the base casting, so try to make sure I'm not steering you wrong, but this is what I've got. For a long time, I've wanted to add a TIG welder to the tools in my little shop, and this year, I finally decided to do it. I got the Prime Weld TIG 225X, which is capable of a maximum welding amperage of 225 amps, and that turned out to be just perfect for this project. There were a couple details I wanted to machine into the square tube before welding everything together, like these little details for the leveling feet. They're just some cutaways that I thought would look nice, and they'd also give me some access to swing a wrench to level the frame. I also wanted to cut in these slots that would give me some forgiveness and alignment when bolting the lasered tabletop to the frame. This tabletop was cut accurately on a CO2 laser, but I'm less confident in my welding fixturing or ability, so these slots are just some insurance to make sure that things will go together no matter how bad I screw up the welding. My plan was to make 2 square frames like these and then stick them together with 4 sort of cross members or cross tubes. I was really nervous in making all this happen. I've wanted to learn how to weld for a really long time, so this was all great, but TIG welding, for me anyway, turns out to be really, really hard. On the bright side though, it turns out that welding this thicker stuff is way easier than welding thin stuff, so this turned out to be a pretty good first project. I started by tacking the square frames together, just doing my best with a square and some magnetic clamps. I wasn't really sure how much things would start warping when I started to really burn in the corners, but they came out pretty nice. When the 2 square frames were done, it was time to try to stick them together. Now things are starting to get really heavy, and I definitely overlooked how I was going to put all these pieces in a position so I could weld them together. But where there's a will, there's a way, and I did manage to wrestle all these pieces together. Again, I started by tacking everything together. I did bolt on the top plate to try to sort of hold things together before really starting to burn things in, which I knew would add a lot of heat and start warping this base. I mean, in a perfect world, this tabletop would have been machined flat, so the mill's base casting would sit nice and flat on this table, but I mean, that's just not the world we live in with these garage hobbies. I've got to say that overall, I'm really happy with the way that things came out. It isn't at all perfect or going to win any beauty contests, but it's definitely going to hold nice and strong, and that's all I think I really need for this thing. One of the last things to do was add a couple of coats of paint, and it's winter in Canada right now, so I can't just wheel this thing outside and hit it with a spray can. That would have been a lot easier, but I had to go the old school method, just a paintbrush and a paint can, and it came out alright. As part of this upgrade, I decided to cut out 1.35 inches of iron from the base casting, which will give me a little more travel in Y. There are arguments out there about this decreasing the rigidity of the mill, and what I can tell you is that I just didn't experience that. In fact, you'll see how much rigidity we actually picked up when we do some test cuts on the new base later in the video. They say that this modification should get you 11.5 inches of Y travel on the PM30, but all said and done, I'm now getting 10. Not exactly sure where the confusion is coming from here, but on my mill, when I cut away 1.35 inches, I'm now getting 10, and I'm not complaining. That's a significant increase for me, and I'm really happy about it. I didn't show it on camera, but I also got rid of the gas strut inside the Z column. That also picks up a little more travel in Z, and specifically, it lets me get the spindle nose right down much closer to the table, which I'll need if I ever decide to get one of these fixture plates. Basically, with these plates, you can hold parts right down on the table and not up a little higher in a vise. And with the gas strut in there, the head just doesn't come down far enough. It sort of bottoms out on that gas spring. I was a little worried that the head might start falling under its own weight when there was no power to the Z stepper, but it doesn't. And I've also spoken to somebody who upgraded their spindle motor to a heavier 3 horsepower AC motor. He doesn't have the gas spring in his column either, and he doesn't have any issues, and he doesn't have any counterbalance mechanism or sort of external Z head assist. I also decided to tack these 3/8 stainless hex bolts to the table. This is kind of just a provision for future add-ons to the base that'll give me some threaded studs on the bottom I can fasten things to. I can see myself adding some kind of catch pan for oil and chips later on. I'm not going to spend too much time on the assembly of the PM30 in this video, but I did get quite a bit of footage when putting it back together, so if that's something you might be interested in, let me know down in the comments. I also ground away some of the back of this base casting that makes it possible to slip the entire Y ball screw assembly back into place with the ball nuts assembled onto it, which is pretty handy. Next, we install the Y table, and all of the sliding tables, X, Y, and Z, they all go on really easily because there's lots of clearance in the dovetails without those gib shims installed. And before connecting any of the tables to the ball nuts, this is a really good time to adjust the gib tightness. You want to make sure that the gibs are basically as tight as possible while still allowing the tables to slide freely throughout the entire lengths of their travel. If you over tighten the gibs, you'll notice that things start getting sticky and stop sliding so nicely. And gibs that are too tight can cause premature wear and also introduce some backlash into your system as the ball screws fight to overcome the sticking forces. It's also a good idea to drill some holes in the X and Z gib shims that line up with the oiling ports in the castings. These are just going to be little passageways that let oil through to the sliding part of the dovetail. You can see that there are 2 oiling points for the X table, but there's only one for the Z head slide, so the Z gib shim only gets 1 hole. Wrestling this spindle head assembly onto the Z column is always a little interesting. It's one of those things you just need a few extra hands for. You've got to hold like 3 different things in place before pushing those carriage bolts through the clearance holes, but just be patient and it'll eventually come together. The last thing to do was to reinstall the one-shot oiling system. I got lucky here because I only had to modify the length of 1 hose, and basically every time you change a hose you need to get some more crimping ferrules because they're sort of sacrificial and they stay on the old hose, but luckily I had that 1 extra small manifold block you can see sitting on the frame that I was able to steal some parts from. The mill's all built and it's time to tram it in. I like to start with the Y, or the nod of the machine, because to correct any nod, we're going to have to install some shims. You can either shim at the base of the Z column or between the spindle head and the Z slide, which is where I like to do it. For my machine, I needed to install a 2/1000 shim on either side of the head. Now we can move on to tramming the head in sort of the X direction, and this is a lot easier because we can just sort of tap the head around until we're flat. There's no shims required here. So our tram is good, and now we'll set up the vices. I like to stone the table and the bottom of the vices, just knocking off any high spots and making sure things are nice and clean. I align the vices to within about 1/1000th and then mill these little grooves into the soft jaws. I prefer using this kind of setup instead of parallels because my vices aren't matched, so these grooves ensure that if I'm holding something across 2 vices, the heights are going to be the same. So it's finally time for the first test cuts, and the point behind upgrading the rigidity of the base was to increase the performance and ultimately the material removal rates that the mill's capable of. It's a funny thing that seems to make less sense to me the more I think about it, but it's true. Even if you don't change anything at all about the mill itself, you don't increase the power of the spindle or the RPM or anything like that, if you upgrade the mill's rigidity and stiffness, you will ultimately increase its ability to cut metal away faster. And this exercise has totally supported that theory. These shots aren't sped up at all, and I haven't fully crunched the numbers yet, but my mill was not able to do this with the old base. I just couldn't plunge an end mill into a chunk of aluminum like this. So if you're planning on converting a bench mill to CNC and you're thinking of springing for a cheap, flimsy base as part of the deal, I strongly urge you to rethink it. You know, when we're buying a mill, we spend a lot of time thinking about things like the power of the spindle and the RPM and things like that, but one of the most important and often overlooked things that has a huge impact on the performance of the thing is the rigidity. And I definitely learned it the hard way, so don't make the same mistake that I did, and thanks for watching. We'll see you in the next one.